All right. Well, good morning, everybody. First, I'd like to thank everybody for taking time out of their busy day to attend our webinar here. My name is Dan Pro, president of Neometrics, and I'm joined by Kelsey Noyes. Kelsey joined us about 6 or 8 weeks ago. She's got about 20 years of engineering and sales experience, and we're very happy to have her on our team to help support and promote our 3D printing and 3D scanning technologies. So this morning, Kelsey will be talking to you a little bit about composite 3D printing, the different materials that are available, the different machines that are available, and then also some great customer applications. Just a couple of housekeeping notes. If you do have questions that pop up, feel free to put those in the chat, and then we will try to address them at a timely manner in between slides in the presentation, and certainly any other questions that we have at the end. With that, I will hand the floor over to Kelsey, and she will go ahead and begin our presentation on composite 3D printing.
Great, thanks, Dan. Well, I want to welcome everybody. I'm glad you attended. I'm looking forward to sharing the next 20 minutes or so with you as we review composite printing. All right. So again, my name is Kelsey Noyes, and I'd like to welcome you all to the Introduction to Composite 3D Printing webinar. I'll start by giving you a brief background of Neometrics. Then I thought it would be helpful to review what composites are. I'll describe the unique Markforged 3D printing process. Then we'll look at various filaments available for both base materials and optional reinforcement fibers. We'll see the current lineup of Markforged composite printers, and I'll show you a variety of 3D printing applications. And then finally, I'd like to share a few interesting success stories. Neometrics has been delivering 3D engineering solutions since 2003. We provide scanning services for reverse engineering projects, also quality control inspections. We have a number of 3D printers in-house available to print parts for customers. We sell equipment for 3D scanning and 3D printing solutions, as well as the related software packages. We provide complete training on all hardware and software solutions. And today's webinar will focus specifically on Markforged 3D printers. And now for the main feature of this presentation. We hear a lot about composites these days and how great they are, but what are they and why are they so great? Well, the simplified definition is a composite is made up of two or more materials, typically a matrix and a reinforcement. Composites offer many benefits such as strength, lightweight, corrosion resistance, design flexibility, and durability. Carbon fiber is popular because it's very strong and extremely lightweight. These properties make it a great choice for golf clubs, fishing rods, and bicycles. Carbon fiber helps to optimize the performance of race cars and even airplanes. We've seen some benefits of composite materials. Now let's see how we can utilize 3D printing to create strong, lightweight, and long-lasting parts. Markforged specializes in the fused filament fabrication process, also known as FDM. A base filament of thermoplastic material is fed into a heated printer extruder head and is deposited onto a platform, one layer at a time. The build platform then lowers as each layer continues to grow the part. A unique option that Markforged offers is continuous fiber reinforcement. Maybe your part would benefit from additional strength or stiffness. A second filament can be extruded at strategic locations to increase the strength of a part. To further illustrate this process, here's a photo of a 3D printer. The filaments are stored on reels and are loaded in the printer. An entire part can be printed using only the base filament, but you can also choose to strengthen your part using continuous fiber reinforcement. The next photo illustrates continuous reinforcing fibers along the outside of the part. This will maximize the bending strength. Next, we'll review which materials are available for base filaments and their individual benefits, And then we'll look at various options for continuous fiber reinforcement. Onyx is the flagship base material, and it's also a composite. To best describe the strength of this unique material, it's helpful to use an analogy of another very common composite we see every day. Concrete is made up of cement, sand, and aggregate. Each individual component will not hold its own shape with any amount of force, but when combined, they make a rigid, solid material. Onyx is created by combining a nylon thermoplastic with chopped carbon fibers. We know that carbon fiber has very strong attributes. Another benefit of this creative blend is an impressive, high-quality surface finish. Parts are both beautiful and strong. Also, Onyx holds its shape. The edges are true, parts look better, and fit together better. Onyx is an excellent choice for so many applications. Functional, with a surface finish you can be proud of. Another, I have to just click. All right, let me just I don't know what happened there. I'll restart this slide. There we go. So what if you require parts to be non-flammable? Markforged developed a very special variant of Onyx, which is flame retardant. You'll still have all the benefits of Onyx, strength, a beautiful surface finish, and it can survive in a flammable environment. Onyx FR is a great material choice for automotive, aerospace, and defense applications. The video does a great job of demonstrating how amazing this material is. Even under a constant flame, the fire does not spread. It's self-extinguishing. Another area of concern may be electrostatic discharge, which may be harmful to electronics. Another variant of Onyx was developed for parts that must be ESD safe and for parts that cause processing difficulties when charge builds up. Onyx ESD is a reliable material it's safe for electronics. Electronics manufacturers can enjoy the benefits of 3D printing by creating strong, high-quality parts quickly while meeting strict ESD safe requirements. Perhaps your requirements are for a smooth, non-abrasive surface, or cosmetics are a priority. You may want to dye or paint the part. Nylon White is an engineered thermoplastic and a great option to meet those needs. It's a strong material but offers a little more flex than Onyx since there are no chopped carbon fibers. We saw a lot of great base materials, but if strength and stiffness are high priorities, we can utilize continuous fiber reinforcement to optimize our parts. Looking at the concrete example, how do we make concrete even stronger? Adding rebar increases the strength and stiffness. Similarly, we can add reinforcement fibers into the matrix or base material of our printed part. We'll review the additional filament choices available for continuous fiber reinforcement. Being able to pair the optimal base filament with the optimal continuous fiber reinforcement allows us to utilize all the benefits of composite materials. This is a quick look at the strength of the various filaments available as continuous reinforcement. We'll be looking at each of them individually soon. Not surprising that carbon fiber is the leader of the pack, but it's interesting to see how all of these fibers are stronger than the base materials alone shown at the bottom of the chart. The first filament we'll look at is carbon fiber. The best combination for strength and stiffness is pairing Onyx with continuous carbon fiber reinforcement. This combination creates parts that are stronger than aluminum. A huge benefit is you get end-use parts and functional prototypes, and they're now easily printed in a fraction of the time it would take to machine those same parts. This Insteron challenge really showcases the strength of the continuous carbon fiber. And we'll see the pounds here, right there in the upper right. Still holding it, 21,000. Still increasing. Wow. I just think that's a great example. Kevlar is a great option if you need a forgiving and durable material. Kevlar is commonly used in bulletproof vests. The goal is to absorb a force and not break at high impact. It's easy to recognize its yellow gold color. Using nylon as a base and Kevlar as reinforcement results in flexible yet very strong parts. Fiberglass is a great beginner reinforcement fiber because it's high performing while remaining inexpensive. This video does a great job demonstrating the additional strength of the fiberglass compared to just Onyx alone. Although I think Onyx should get some credit for holding on to that weight. And last, but certainly not least, is high strength, high temperature fiberglass. This reinforcement fiber comes in second in strength, just after carbon fiber. It's strong in both low and high temperatures, but it's ideal for use in high temperature environments like autoclaves and molds. A great combination would be using Onyx flame retardant with high strength, high temperature fiberglass for a welding fixture, for example. All right, and as promised, here is today's lineup of the Markforged composite 3D printers. We have two series, the desktop series and the industrial series. How do you choose a model? Well, you want to start by identifying your needs. What size are your parts? Are there any strength requirements? Do you have any high temperature or ESD requirements? Do you want the ability to customize many different designs for new projects? I'll give you a brief overview. So the flagship printers are on the left. That's the Mark II and the X7. And they're capable of printing all of the materials we have reviewed today, allowing you the flexibility in designing the ideal part for many applications. In the middle, we have the Onyx Pro and the X5. This is a more simplified option. You can print with Onyx as the base material and fiberglass as the continuous fiber reinforcement. And then finally, we have the Onyx 1 and X3 available. They're base models that do not use continuous fiber reinforcement. You can print your parts completely in Onyx. All right, and now for some 3D printing applications. The interesting thing is in the early days of 3D printing, the primary application was basic prototypes. Today, since we have the ability to use more advanced materials, the applications have grown considerably. So I'll share a number of these with you now. End-use parts, the strength and durability allow for functional, complex parts at reduced costs. Tooling development, you're able to quickly print complex geometries that cannot or not easily be machined. Service or maintenance, easily create custom tooling or fixtures that ultimately reduce downtime, saving money. And functional prototypes and testing. You have the ability to evaluate actual part properties, make design changes, and then quickly print new iterations. It takes the guesswork out of engineering, not having to rely on only basic, simple prototypes. All right, now we have a few success stories. This one is a company in Italy that used a lifting tool to move really heavy engine parts like pistons around their factory and also cargo ships. The previous lifting tool was machined out of steel, but they found this was too expensive, too time intensive, and really too heavy for people to transport. They redesigned the part. They used Onyx with carbon fiber reinforcement, and they were thrilled with the results. The 3D printed part, they were able to reduce the weight by 75%. They saved over $120,000 in just 8 months. The tested lifting capacity was 1 ton without any deformation. There was a required safety factor of 4, so the certified lifting capacity was 529 pounds. Still very impressive. Fisher Connectors needed to produce overmold tools for the military. The military operates in unforgiving environments, so they need robust connectors and connectivity solutions. They competed with other companies to make these molds, and turnaround time is key. 2 to 4 weeks and $5,000 per part made this very challenging. 3D printing changed everything. High strength, high temperature fiberglass was selected in order to resist deformation. The mold tool is clamped down at 30 tons and heated to almost 400 degrees Fahrenheit. They can now print these molds in 1 to 2 days for $150. They can be much more competitive and more easily win bids. Alcon manufactures contact lenses, and each lens must go through multiple inspections. Some of the inspection lines are automated, but whenever there's an upgrade to the line, they need custom bracketry to retrofit the new equipment into the existing line. And machining custom brackets, that was a difficult task. It could take 4 to 6 weeks to arrive, and that's if they found a job shop willing to take a one-off order at all. Having a 3D printer on site enables them to save time and money. Downtime in production is always expensive. Having custom printed brackets for $40 in just 1 day is a huge benefit. But more amazing is the decreased downtime on the production line. All right, and then this is the 3D printing survey that we're hoping you would fill out. The link is available in the top portion of the chat. So if you could just click on that and just answer a few questions. We're just curious to see how you're currently using 3D printing. And then otherwise, that concludes the presentation. I'd like to thank you all for joining us today. And as a reminder, we do have printers here. So if you would like us to print any parts for you, feel free to send me a CAD file. My email and my phone number are on the screen, so feel free to make a note, and definitely reach out if you want to discuss any projects or if you have any questions specifically about the 3D printers.
Okay, it looks like we haven't had any questions come through the chat, so we'll hang out for a few more minutes. If you do have some questions, feel free to submit. And we'll hang out here. Otherwise, if you do have any thoughts or any questions moving forward, feel free to email Kelsey. Her email address is up there. Finally, I'd like to again thank everybody for taking time out of their busy day to view the presentation, and we look forward to hearing from everybody. Thank you. Oh, so it looks like we did have a question come in from Dawn. What can a 3D printer not create? Kelsey, do you have any comments on that one?
What can it not create? It can create so many things. Can you think of anything, Dan?
So 3D printers they're somewhat limited. Well, not somewhat. They're limited by their size. So very, very large items, unless you have a very specialized large format 3D printer, would be difficult to print. And likewise, also very, very tiny things. So each different technology has a range of sizes that it works with. So if we look at the desktop series that we have from Markforged, you're basically looking at parts that would fit inside a shoebox. With the industrial series, you probably get about 4 times the build volume, so slightly larger than that. But that's really the only limitation is going to be the size. If the CAD file fits inside the printer, you can very, very likely make the part.
Good question.
And I think that appears to be about it.
Great.
So again, thanks everybody for coming, and we look forward to seeing you at our next webinar. So look forward to the email invitations for that one.